This is the beginning of chapter 5.2. We're going to look at the first two objectives, which is using the addition rule for disjoint events, and then using the general addition rule. So um, we just finished the probability of simple events, and now what actually happens in the real world is that events get a little bit more complicated. There are multiple events happening, and so our first one has to do with the idea of um, looking at events and asking what's the probability of this happening or this, kind of like multiple things going on at the same time. And so some terminology we need for this section: two events. So one of them is called disjoint. Two events are disjoint if they have no outcomes in common. And we'll look at some examples. Another name for disjoint events is, and this is a little bit maybe more technical, mutually exclusive. Exclusive events would be another word. Many times the way we look at to analyze this is through um, kind of Venn diagram. So again, you've seen this in Math 83. If Venn diagrams don't have any overlap, so thinking of all the numbers, um, thinking of like different groups of values. For example, in this case here, which comes from the book, if we look, each chip is labeled 1, 0, 1 through 9. Let E represent the event that you choose a number less than or equal to 2. And F be the event that you choose a number greater than 8. So those are your outcomes. Because E and F have no common outcomes, they are disjoint. And so that's an example that we're talking about. Okay, where rules don't have, where the events don't have something in common. So that's the first analysis we're going to do. And so we have some addition. Um, we have some rules that we follow for that, and you can see them here. State the addition rule for disjoint events. And so looking at this here, if E and F are disjoint, means they have nothing in common, the events, then the probability of E or F is just equal to probability E plus F. In general, if we're looking for more than two outcomes and none of them have in common, it's just the sum of all of those probabilities together. And so again, it's better to look at some examples so we can see what we mean by disjoint events. But examples of that, think about think of two events that have no outcomes in common. Rolling a die and then and flipping a coin. There are no common outcomes. They have different things. So that's a common, again, gambling one. Rolling a die and flipping a coin. The outcomes here are 1 through 6. The heads or tails. There's no outcomes in common. Um, so I want to make sure we're kind of thinking about that. So let's look at some examples with that. A deck of cards and the addition rule for disjoint events. So here are all the, if you're not familiar with a deck of cards has 52 cards, and they're labeled A through Ace through King, and they have different symbols. So those are called suits. Those symbols are called suits: spades, hearts, clubs, and diamonds. And so in this case here, compute the probability of the event of drawing a king or drawing a red 4. And so in this case, drawing means to pick, in case you're not familiar with some of the gambling stuff. To draw means to pick, to choose. Okay, so what's the probability of drawing a king or drawing a red 4? And so in this case, this is just equal to, going back to our formula above, it's just the sum of those two probabilities separately, because these are disjoint events. Drawing a king and a red 4 are not common outcomes. And so this is really the probability of drawing a king plus the probability of a red 4. And so what is the probability of getting a king? There are 4 kings, so that would be 4 out of 52 plus a red 4. There's 4. These are red here, and so that gives us 2 out of 52. So the probability of choosing those are 6 out of 52. And so that's an example of using disjoint events, the addition rule. Compute the probability of drawing a king or drawing a queen or drawing a jack. And so in this case, we would use probability of the king or a queen or a jack. It's just the sum of those probabilities separately, because these are disjoint events, plus the probability of a jack. And so the probability of king is 4 out of 52. Probability of a queen, there are 4 of them, 4 out of 52. Probability of a jack is 4 out of 52. So that's 12 out of 52 is the probability of picking of picking a king, queen, or jack. Okay, and then let's look at, again, that was more the general. That was the rule for disjoint events. There's another rule just in case two events are not disjoint or not mutually exclusive. And in this case here, we have a different formula. So you got to be careful now. This is when we're talking about an or situation. It still is the sum. The only difference is we have this here. So this case, again, we use this case here, use this rule when the events are not disjoint, right? There's some common, and so what you're going to end up is subtracting out any overlap here. And so that's what we're doing here, explaining why we subtract this out. And so in this case here, we're looking at that, and so we want to explain that. So in this case, we need to subtract out because there is some overlap in those events. So what I mean by overlap, we go back to a Venn diagram to show you that. And so if you look carefully, a Venn diagram will show you here that you can see in the previous one, this circles those events didn't have any overlap, so there was nothing to subtract out. In this case, there's an example where there's an and part, that this belongs to both E and S, and so that needs to be subtracted out. Otherwise, we're over counting. And so the reason we want to subtract out is we subtract out to avoid over counting. And so let's do one more example. Computing the probabilities for events. So let's go back to this picture here. And so suppose a single card is selected from a standard 52 card deck. Compute the probability, in this case here, probability of choosing a king or drawing a diamond. And so in this case, drawing a king or a diamond, there's overlap, because if you look at the deck of cards, there is a king that is a diamond. So there's one card that's overlapped. There's overcounting, but we'll break it up this way. It's the probability of a king plus the probability of a diamond minus the probability of a king and a diamond. And so in this case, the probability of the king is 4 out of 52. The probability of a diamond, there are 13 diamonds. So it would be 13 out of 52. And then minus the king and the diamond. And in this case right here, if we look at this, this is the one right here that is a king and a diamond. So there's one that we would consider a king and a diamond. And so then you subtract out 1 out of 52. So this answer would be 16 minus 1, 17 minus 1. So it's 16 out of 52. And again, you would change that to a decimal. So we have that. Let's finish this one on before this video gets too long on this here on using tables to get it, which we do a lot of probabilities. So A, determine the probability that a randomly selected U.S. resident 15 years old is widowed or divorced. So this is a table of residents 15 or older. So in this case, A, we want the probability that it's widowed or divorced. And so that's just the probability of widowed plus the probability of divorced. And notice here, widowed, there are 3.1 and 11.2 million people, so that's 14. And divorced, there is no overlap on A. There is no shared outcomes. These events are disjoint. So we just use that formula there. And so the probability of all of this is going to be probability of widowed is going to be 3.1, 11.2, that's 14.3 all over the total amount, which you'll get right now, plus the probability of being divorced is going to be 25.4 divided by the total amount. If we add up all of these totals here, you get 251.3. 251.3, so this is going to equal to 39.7 divided by 251.3. And we do want to put those into decimal, so that would be 0.158. And then part B, we're looking at on part B, we're looking at the probability that the resident is male or widowed. Male or widowed. And in this case, if you look carefully, widowed are this group here. Males are this group here. So what I can see is there's overlap right here. There is what we call overlap right there. So to get this answer, it's going to be the probability of being a male, which we add all those. This has to add that up. 41, 64, 3, 11, 2.1. The probability of being male or widowed is going to be, so you add all that up, that's going to be 122.5 over 251.3 plus the probability of being widowed. Widowed was 14.3 over 251.3, and now we're going to subtract out the overlap, which is 3.1 over 251.3. And so when we put all that together, you get 133.7 over 251.3, and then that simplifies into 0.532. And so notice we had to subtract out because there was an overlap here. These events are not disjoint.